Good evening, everyone. How are you? So we will start the session in around 15 minutes at 8:30 p.m. IST. In the meantime, please do introduce yourself. Do let me know about your background. Which clouds do you work on? And do you work on machine learning? If you work on machine learning, then which frameworks have you deployed? Which frameworks have you worked on? Which models have you deployed? What are your which programming languages are the preferred ones? So do let me know about all that, right? So please do introduce yourself. We will start the session in around 15 minutes at 8:30 p.m. IST. Please introduce yourself in the chat window. Now, apart from that, couple of housekeeping information. Sometimes the live stream on LinkedIn reduces in quality. Uh, so if anything like that happens, please move to YouTube. I will be putting the link of the all the platforms we are streaming on right now in the chat window. So you can watch us on, you can join the session on YouTube. You can also uh, can see it on LinkedIn as well, and we are live on Facebook as well. So just FYI, the quality of stream on YouTube is generally better than other platforms. So please move to YouTube in case if anything goes wrong. And let me know about your background. Let me know about your clouds, about the about your knowledge of machine learning. Please do introduce yourself. We'll start the session in around 15 minutes at 8:30. So I'll just mute myself till that time. So everyone who have recently joined, please introduce yourself in the chat window. We will start the session in some time. We'll start the session in now in approximately 12 minutes like that at 8:30. So I'm pretty sure you have the agenda with you. In case you have any other expectation from this session, then let me know. And let me know about your background. Please do introduce yourself. So we will be starting the session at 8:30. In the meantime, please find some time to introduce yourself. Do let us know about your background, which clouds do you work on? Is Google Cloud Platform something which you work on, or is it something new? Are you already familiar with machine learning? We will be deploying few models today, and we'll deploy one of them will be a convolutional neural network. So do you already know what is max pooling? What is the meaning of convolutional layer as such? Please do introduce yourself in the chat window. So in next 9 minutes, we'll start this session. If you have any specific expectation from this session, then do let me know about it. And do let me know about your background and also from where you are joining in. Start the session in next 5 minutes. Please let me know about your background. Which clouds do you work on? Is machine learning something which you already work on? Is it something new? Do you already use Vertex AI? Have you explored it? And or any other platform as well. Maybe you're working on maybe you're working with the Azure machine learning service, or maybe if you're working with Amazon SageMaker, then you can give me some pros and cons between that. Which platform do you like more? Any feature of any of the cloud platform machine learning offerings which you like more than the others, right? So please do introduce and do share your thoughts in the chat window. We'll start the session in next around 4 to 5 minutes, right? I'll just go through your introductions in the chat window. I'll just read them. And FYI, we are live on all the three platforms: LinkedIn, Facebook, and YouTube. And based on the previous experiences, uh, you guys might have joined us for the previous webinars as well. So based on the previous experience, uh, the stream quality of YouTube is pretty good. And sometimes the LinkedIn stream quality dips without any reason. So just make sure that you if anything like that happens, you know what to do, right? Move to YouTube's stream. And there is one question which every time people ask is that where is the recording of this session? So on the same link, for example, if you have joined the event, then we will be posting the recorded link of the session on the same event page. And if you're joining us on YouTube, the same page where you are on, after the stream, the recording is automatically rendered and provided there by YouTube in the same location. So if you bookmark the YouTube link, or if you come back to the event page in few days, you will find the recordings there. Now we do a lot of webinars, so in case you are looking for learning new technologies, if you're interested in Kubeflow, there is one webinar coming on Kubeflow, another one on Azure DevOps on next month. So if you are interested in these new technologies or new, uh, you want to learn new skills as such, then please join the company page of Tech Scalable, and you will get all the updates over there. So please do introduce yourself, and we'll start the session in few minutes. Right? I'm pretty sure you have the agenda with you. I'll walk you through the agenda again. And today the session is on Vertex AI. We will be talking about what is Vertex AI. Uh, we can even compare it with Azure Machine Learning uh, as such. So we can see which platform performs how, or what's the difference between these platforms, right? So that thing is something which we can also add on the way in the session. So we'll start the session in next 2 minutes. I'll just mute myself, and we'll start at 8:30. So let's get started and welcome everyone. Thanks for joining for the session and let's get started. So I have a slide deck with me as well, but as you know that we do mostly demos and whiteboard designing. So the same thing you can expect from this session as well. But before we start with the session, let me introduce Tech Scalable. We basically provide training and consulting on multiple technologies. The main focus is on cloud, DevOps, machine learning, data science, and artificial intelligence. In case you are looking for consulting or training services, then please do reach out to us. We will be sharing the details in the chat window. My name is Shivam Sharma. I'm your speaker for the day. I basically work in cloud and machine learning and data engineering field. And today the session is on Vertex AI. Just give me 1 second. Let me quickly find the navigation bar. Okay, great. So let me walk you through the agenda which I have. Just give me a second. Oh, it seems that I have not created the agenda slide, so I'll just quickly open the event page, and I'll show it to you over there. So please check this out. So basically, we are talking about Vertex AI, and this is one of the offering from Google from the GCP on the GCP cloud platform. And this is that one platform. This is that one solution in GCP which combines everything together, right? So we'll see what it does. So we'll talk about the Vertex AI capabilities, features, AutoML end-to-end integration from the point of view of data and AI, and we will also see that we will have few demos of how can we train data sets and so on and so forth with Vertex AI. Now, apart from this, there is another announcement. There are giveaways. So, as part of the giveaways, we will be uh, there is a book sponsored by Pact, and this book is on building state-of-art models from scratch with advanced natural language processing techniques. And how do you get the giveaways? So there will be a quiz in the end of the session. At the end of the session, at around 10:15, like that, approximately at that time, and the winners of the quiz will be given the ebooks as such. So we will be having around six lucky, you can say, out of the winners, six of you will be getting the ebooks over there. So this is something. For this you have to wait till the end of the session. The quiz link will be there in the chat at around 10:15. I'll also let you know about it, so you can go and uh, attempt the quiz. Okay, so let's get started. I'll take you to my uh, Vertex AI page, and I'll try to keep the session as hands-on as possible. I'll try to keep it as you can say demo-oriented as possible, right? And I'll be using a lot of whiteboard. Just give me 1 second. Let me quickly minimize. Maybe just close it for now. Okay. So okay. So how do we get started? Like, what is Vertex AI? How do we learn it? What are the various components of Vertex AI? What is so special about it? What is this offering? And so on and so forth. Now, to understand the offering, I basically will break it down into smaller pieces as such. Now, if you understand the elements of Vertex AI, you will be able to understand the service, the SDK also, and how do you use it, where do you use it, when do you use it. So to give you a gist of it, let me just quickly go back to the Vertex AI page. Now you see this dashboard, data set, features, label task, notebook, pipelines, training, experiments, models, endpoint, batch prediction, metadata. So these are various elements in Vertex AI. We'll talk about them over here. Okay, so let's get started from somewhere. Let's start from this data set from here, right? From this option, data set. So let's understand what that data set means. What is the purpose of this data set? Now, uh, whenever you do machine learning, there is another there is a couple of problems will be there which you have to face. One of that problem will be, for example, that how are you going to ingest your data? From where are you going to pick up your data? Is it going to be in some sort of relational database? Is it going to be in a semi-structured database, no SQL database like that? Or maybe it's going to be in object storage? And how do I basically ingest it? And once I ingest it, how do I analyze it? How do I create some statistics on top of it? And then I transform it, and then I further use it for my modeling purpose. So what they have done as part of the Vertex AI, basically the very first element which is there is called as managed dataset. Right, the option which I showed you, the full, you can say the full term will be like managed dataset. So managed dataset. Now when you will have your data, the I'll tell you more details about it, but when you have this data set, basically when you have the data, your data might be labeled or it might be unlabeled also. So if your data is not labeled in that point in time, one of your problem statement will also involve the labeling task. So I'll show you what do I mean by that. But if I just put it here, let's say we are doing some labeling as well. Labeling task needs to be done. Now, uh, how many types of managed data sets are there? Let's go back and have a look at that. So if I take you back to my Vertex AI page, you will notice that I have created a lot of I have some demos ready with me, because the training sometimes takes a lot of time, so I have the backup ready with me. But if I just click on the data set option over here, you will notice that there are four options here: image, tabular, text, video. So image is having further four type of options inside it, that we can do single label classification, multi-label classification, object detection, image segmentation. With tabular dataset, we can do regression, classification, and forecasting is also available now. It's in preview. If I click on text, then we are talking about some single label text classification, multi-label, entity extraction, and sentiment analysis. You want to figure out what the people are speaking about the company on Twitter or so and so forth. Now with the data, with the video data set, this is where we can have the action recognition, video classification, and object tracking. So you can create these various type of data set. Now whenever you click on any one of them, let's say I click on the image and I say I want to create it, right? I want to create it. So what happens? They will request me to provide some location where this data can be stored at the backend. So the storage location is the cloud storage buckets, like the object storage, the cloud storage buckets in GCP. Those are the backend locations. So this is the cloud storage bucket, right over here. Now, so data is going to be uploaded inside these buckets as such at the backend, and that is from where the data set, the managed data set is going to store the data at the backend over there. That's how I can represent it. Let's say this is the data set over here. So if I take you back to my GCP page, let me quickly open the page again. You will notice that there are some options here. They are saying that upload your image from your computer. That's one option. If you have already uploaded your data in the cloud storage bucket, then you select the third option, and then you select that particular bucket, and you select the specific folder or path, and then you click on create after that. So that is one of the option where we can keep our data as such. Now another option is there in case you have maybe, for example, let's say if you have a file and that file is having a list of the URIs where the image and the you can say labels are stored. You can also provide those files, and from there the service will be able to pick up the data. Now what I have done, I actually have uploaded a lot of data in multiple cloud buckets. Let me just quickly show you what do I mean by that, and I'm gonna just walk you through the steps as well. How do we create these uh, the you can say how do you upload and so on and so forth. So if you see that I have these multiple buckets over here, and in these buckets, I think this is the one which I created. That was one of the first ones. So you see some data set is there, bird data set. If I click on it, then there will be more pictures will be there inside it. Maybe I can click on one of one of them and show it to you. So okay, this is, I can show it to you over here, right? So some data is already, the pictures are already there as part of the in the buckets. So now when you create, so when you create these data set, they basically look something like this. Let's open a couple of them. So you see, I already have tabular data set with me, image, text, forecasting, video, and so on and so forth. So let's open a couple of them, and let me tell you the details which we are supposed to know from these. And okay, so this one is the video classification data which I have used. Now if you can see, these are literally videos over there, and you can figure out the action from what is going inside the video. That's one of the things we can do with it. Now we have some labels. So this data is already labeled. You can see the labels are here: football, golf, pull up, and so on and so forth. Let me go to the original labeling. So this is the original labeling as such, that riding a horse, pull up, kickball, uh, cartwheel, and so on and so forth. So now what happens if my data is not labeled, right? Let's say you got some videos, you got some text data or something, but your data is not labeled. You don't have that target attribute in the data set. Then how do you handle it, right? They have given one offering to help us in that scenario, but this one is, I already labeled this data as such, or this data was actually already labeled when I got this data, so that issue didn't happen. But if I show you other data set before I take you into another thing, this is basically diabetes data set, the toy data set which we use for diabetic, for classification. You can run any, you can say, binary classification algorithm on top of it to understand that uh, that whether the patient is diabetic or not. So once you create it, you can generate some statistics also on top of it. If I can see that age, body mass index, diabetic pedigree, uh, whether you are diabetic or not, two classes are there. Blood pressure values are there. Patient ID, plasma glucose label as such. Pregnancy, serum insulin, and other attributes are there. So I clicked on that generate statistics. It should give me more values in a minute or two. What we are expecting is that it will tell us like percentage of the missing values, and more details about these attributes over there, whether they are categorical, whether this is integers, or what type of values do we have in that particular attribute. So that is that statistics. I think it will take few more uh, minutes for it to generate. So in the meantime, let's have a look at the other data set which I was opening for you. So the first one was the video one. If you're working with any video based analysis, then that's the one you can go for. This is the simple classification. Here we have the flower data set, and if you see, there are multiple classes over here: roses, sunflower, tulip, and daisies, and others as well. So uh, right, in this manner. So we can think of convolutional neural network. On top of this, we can think of let's say you may have some sort of maybe you can do classification, you can detect the, maybe the we can do segmentation of images, and many more things can be thought through. Now this is another example which I have over here, representing the text data set. So if you see in this attribute, basically we have my eldest son, who is 27, just got a word that he has a new job after finishing the bachelor's degree or something, right? So dinner tonight was really good. I was dropping off my son for a sleepover. I'm excited to be here. My brother told me he got into the med school. So different labels are there: achievement, bonding, uh, and so on and so forth, right? So text classification type of problems. If you are trying to solve that, then the type of data set you have to create, or the type of managed data set that you have to create, is going to be that text oriented. Now, so as I was mentioning, that the backend of this will be cloud storage bucket, and the labeling task can be created. So in case you don't have the label data set, then what do? You simply come to you click on this option over here called as labeling task. You click on this, and then you click on the create task from top. I may have some options with me, but I'll click on create task from here, and then I can select on which data set do I want to do that. I maybe want to do it on the flower data set. I want to create another new set of annotation, and you have to give it a name. So let's say demo set as such. And do you want to use active learning or not? So active learning is the meaning. So meaning of active learning is that you label some of the data, and rest of the data machine learning algorithm will label it for you. So if you enable it, then that can happen. So now if I click on continue, it's going to ask me that what are the labels which, this is a scenario where your data is not labeled, right? So imagine you got that flower data set, but now you have no labels over there. Then how do you handle it? What do you do? You basically create this labeling task. You specify, do you want to use active learning or not? You specify the labels over there. So we'll say sunflower. We'll also say tulip, and other classes which were there. You add those classes, you say continue. Now you also have to specify the instruction document. Now who is going to label it, right? If you think it through, like, we need someone to label it. Now you can hire your own team. You may have your own people who will humanly label that particular data. And if you imagine, if you have 100,000 pictures, then you need a big team to do that. It's going to take some time, right? But if you really don't have labeled data set, or you can go for the active learning also, but in that scenario you have to label some percentage of the data yourself, and rest can be done by the system. So now uh, what is this instruction? Basically, now to those people who will be labeling the data, how do you instruct them? Like, they should have some instructions, right? Like, what needs to be done, what are we expecting, and so on and so forth. So those instructions needs to be provided. So I think I have one dummy file with me, and I have it in this bucket over here in this folder instruction. That is the one. It's basically a dummy file over here. Just want to go next, right? So if I click on continue, now this is what I wanted you to come to, that even Google is providing these services, meaning you can have Google managed labelers as well, who will put the labels over there. And yeah, definitely there will be some extra cost involved in that process, but you can go for that, or you can also go for your own workforce who will label the data if you don't have labeled data set and you want to do some supervised learning or something. So how many labels per term? Who's going to do it? I just created one team called as Team A, hypothetical team. There is nobody right now doing anything. Email ID, just to like, you will be notified on that email ID that the labeling task has been completed till 10%, 20%, or some other percentage will be there. And we'll say, yeah, let's do it, and start the task. As soon as you start the task, right, as soon as you do that, basically this is going to happen. It's going to look something like that. It's going to rotate over here saying running. I think I have stopped that one. I have canceled the first one, but these two are still running. So I already have this flower labeling task right now going on. So if I just open this page, uh, here we don't get much information. It's just like the more information about that labeling has been started and how much percentage has been done. Do you accept this or do you reject it? So those type of information will be there on this page, right over here. Now how do I label my data? Like, okay, so somebody has to do it now. So what they have done, if you want to label your data, just go to the dataset option, and that dataset was flower dataset, so it should be this one. And if I click on it, let's wait for it to open up. And if you see, so this was the original data. So we have created the new annotation here, like that. So now you can label the things yourself, like, so this is basically, I think it's not okay. So let me just try. So okay, I only gave two labels over there. See, sunflower and tulip. I didn't give rose. And I think I have selected all of them, and selected sunflower last time, because you can see every flower is sunflower. So yeah, that's wrong. So basically what I need to do is, I will say that, okay, so let's add roses over here, and let's label the data. So okay, so something like this. So you select all of them which are there. It has not saved it yet. Okay, So let me do one thing. Let me just select the tulip. I think that's the tulip over here. And let me say assign label. And this is tulip and save. So now, uh, when you have a team doing this, this will be done way faster, right? So if you have X number of you can say flowers, I have around 3,667 as such. So I really need a team to help me out, or a couple of people to help me out to do this over a period of time. So I can create this labeling task, and we can label the data, and then we can do supervised learning with it, and for we can take it further. Now comes the next part. Like, first thing is you got your data. So what we have done, we were able to ingest the data, we were able to get the data, and the backend of that data is stored in the cloud storage bucket, and there we will create the folders and the data will be inside it. Now then what do we do with it? Second thing is, like, you have to create the machine learning model. So now when we talk about modeling, there are two concepts which we can go for. First is AutoML, automated machine learning. So if you have a managed data set, you can do automated machine learning, AutoML, right? Like this over here. You can also make your own custom code, right? Second thing is called as custom code creation. We'll have a look at it in some time. So this is the custom code. So you use Jupyter Notebook and you basically create the custom code over there and you work with it. Now, when I talk about AutoML, so let's differentiate between them. So what are we doing right now in this step? We are doing the training right now. So this is the training part. Now what Vertex AI provides is the very first thing we have to understand is when to go for AutoML or when to go for the custom code. So what to explain that part, I have basically opened their documentation in my secondary screen. I'll just show the documentation to you and I'll walk you through that particular differentiation or differentiating factors between when to go for AutoML, when to go for custom training in their documentation itself, in GCP's documentation over here. You can also just Google it up and find this particular page. Now, if you see, if you don't have data science expertise, then AutoML is one of the go-to way of working. If you are doing custom training, then you need to have the expertise with you. Then only will you be able to train your machine learning models, right? Now, if I have so AutoML is codeless. I will be showing it to you once we go through the differentiating factors as such, and you will see that we are just selecting a couple of options over there, and it's next 10, and the thing works out in that manner. If you need to have development experience, then only can you do custom training over there as such. Now time to train the model is generally lower in the AutoML. Things are more automated. You start the job and you just go and have a coffee or something, or maybe you just you come back in some time and the job will be finished in that point in time, like that. So in terms of the training time will be higher when you write your own custom uh, models. There are some limits in machine learning. Now when you do AutoML, there will be some predefined objectives. You cannot do everything. There will be some very preset things which you can select from the UI, and then only, or maybe from Python SDK, but then only can you do that part. You cannot do customization into it. That's basically that's why we call it automated machine learning. But in custom training, we can do everything over there. So now, can I optimize the hyperparameters in AutoMLs? The hyperparameter tuning is sort of inbuilt. Like, everything is part of the offering itself. You specify that hyperparameter tuning needs to be done, and it's gonna do it right for you. It's gonna find those perfect, you can say, as optimized as possible pairs of hyperparameters by which your model is as optimized as it can be. In custom model, you have to think about it yourself. Now before I take you to other points, let me just quickly show you what that AutoML looks like. So let's open the let's go back, and let's go to the home page over here. And if you see this training option which we have, if I click on the training option, you will notice that we have training pipeline, we have custom jobs, hyperparameter tuning jobs are there. So three jobs are there on the top. I have few options already. If you see the time required to run it, all of these. So this first section is all is mostly basically this is mostly AutoML over here. Maybe few of them are custom models which you can see from this tab. So 1 hour, 10 minutes, 3 hours, or so three, four, approximately 4 hour, 2 hour, 123, 55 minutes, 35 minutes, and so on and so forth. It took some X amount of time. Now, how do we train the models, right? You click on this training method. Basically, uh, if you have a managed data set, right? If you have a managed data set, you can do both. You can do, so if I click on, let's say, managed data set, and let's pick up a small data set first, diabetes classification, you will be able to do both AutoML and you will be able to do the custom training as well. Now, if you don't have a managed data set, meaning you have some sort of third, you don't have a preset data set, you have any other source, you are getting your data from maybe from any other you can say service of GCP, someone is streaming your data, BigQuery is there, maybe there is a big table from where you are getting the data. So any other custom source which is there, in that scenario only custom training can be done. So if I just complete this diagram over here, I can get my data from other sources as well. So let's say other sources over here, right? But from in terms of those other sources, we are saying that you will only be able to do custom training, or custom code needs to be written in that particular in that particular case. So just give me a second. This is other sources over here, right? So what are other sources? BigQuery, right? Other sources can be Bigtable. So like this. Now this arrow will go in this custom code. Now how do I so uh, okay, so that's just to complete the diagram. Now let me just take you back, and I will just quickly complete that step over here. So if we don't have any managed data set, then that custom training comes into picture. With a managed data set, you have both the options with you. So what I'm doing, I'll take you to the video classifier or maybe text classification or something which is small, maybe a binary classification over here, and we will click on any one of them for now. We clicked on the first option, and now what's the target attribute? So in the diabetes data set, the target attribute is the diabetic column, right? Binary classifier, basically 0 1 over there. So whether you are diabetic or not. So diabetic is the Y attribute, and let's say continue. Let me show the advanced option first. So there are various methods in which you can do the data split. You can have a random split, you can have any other manual splits as well, which you can select from this. And some other options are there for encryption purpose. We'll leave it default. We'll not click on the encryption right now. And then as part of AutoML, it is asking that do you want to do any further transformation, like if you have categorical data, what encoding do you want me to do, what do you want to do on some other type of data. So if you have anything in mind, you can specify those extra details. Otherwise, let it be the way it is, and the AutoML will take care of the data cleaning, data pre-processing itself. It's going to handle it. So both options are there. I can also specify more optimization objectives, like what is this AutoML is supposed to do, what, like when it is doing the model training, then what to optimize. You're trying to optimize the AUC ROC curve? And there is a question which I have for you. What is the range of you can say AUC ROC, if anybody knows that range, and the meaning of it as well, like if I have a value equal to something or less than something, then what is the meaning of it, which is a good classifier when the classifier is a random classifier. So do let me know about that range in the chat window. um, so you can specify these details. Otherwise, some default values will be there. So we'll say continue. And now it is asking that, okay, what is the budget which you want to allocate to this training right now? If I have a smaller data set, smaller budgets will make sense. But if I'm doing some sort of deep learning convolutional neural network training, then a bigger budget will be is there. Now, I'll tell you one thing. What it does, what Vertex AI does, if you have a very big data set, if you uploaded maybe hundreds of or thousands and thousands of pictures, right? And you go and you are trying to set a very low budget, then it's gonna throw it. It will not let you save it. It will say that uh, that for this size of data set, I need minimum this much time of training to happen. So when I was training my model on the on one of the data set which I uploaded, the minimum time was approximately 8 hours, right? But when the training actually ran, when the model actually ran, this early stopping came into picture. So early stopping are the exit criterias, like when should the model should exit, when should the exit happen. Like in 𝐀𝐠𝐚 we have the exit, right? If the centroid is not moving, then why should we waste the training resources? So similarly here also exit criterias are there, and these exit criterias are will make sure that you don't waste the budget or you don't waste the compute. And as soon as the maximum optimization is achieved, if it is not improving further, if if it's the best model and you gave 8 hours of time and it was found in maybe 20 minutes, then the termination of the run will happen after 20 minutes, so you don't have to pay for rest of the running time. Everything will stop, like the training will succeed. So for now, uh, we'll give it as one. Now here we have few uh, you can say recommendation is there. Like if you want to estimate this, sometimes people ask this, right? So when you go to client side, generally your customers will ask that, like if this is what I am doing and this is my data set, then tell me how big a cluster do I want. So this is that little uh, recommendation from GCP, from Vertex AI, that what should you do. Now I'll give it as 1 hour, and actually one is the minimum time as well. So if I give you, the number can be between 1 and 72 hours as such. So 1 hour is the minimum time. I cannot give less than that. So I'll give the minimum only. Right now, this data set is very small, diabetes data set. So training should not take much time, but you click on start training and the training will start after that. So how does it look like? So here I have trained multiple models. Like it's you can see that I have the this is basically a custom model. So we'll see it in some time. Text classification has been trained, diabetes classification has been trained, video classification, flower classification, and because of some reason it got trained 2 times. So another diabetes. So I think that's the same one. Let's use the previous one. So this is the output of text classification where label where we are doing the where these are your classes: enjoying the movement as such, exercise, nature, achievement, and so on and so forth, right? So uh, you have all the matrices. Have a look at this. So these are basically the matrices which are there from the point of view of training the model. Like what are my matrices? Do I what is the precision value over there? What is the recall and accuracy? Total items, training items, validation item, test item over here. You can change the confidence threshold as well. And if I just scroll down, the confusion matrix is here. So true labels and the predicted labels are on the top, and this is your the correct classifications are on the diagonal line, and misclassifications are there apart from this. So over here, if I click on other options like model property, so it will tell me like for how much time it ran, and other details will be there. Like status is succeeded, training time 4 hours, a little less than 4 hours. Where did we train it? uh, 80 10 10 was the ratio in which the data was split. And training items are 80%, which is 9555. 10.1% is the validation data set, 1207, and test is 1185. So right, AutoML was used, and the objective was to achieve text classification single label. So this is what we actually were trying to read in the documentation, that it's possible that the objective which you have is not supported yet in AutoML. It doesn't support it. Like um, you have some custom requirement, then you cannot use it, right? So you can control some aspects of the training environment, like there will be some limitations, but yeah, you can do a few things over there. You can specify the number of node hours to train for and whether to allow early stopping of the training or not. You can also specify other things in the custom training. So there's some limits on the dataset as well. AutoML will use the managed dataset. Data size limitations may vary on the type of the dataset. So, right. So this you see this arrow, managed dataset is the one which is used for AutoML. Now let's just minimize this for a point for this point in time. Let's see other values over here. Now I'm going to diabetes classification, and you will see that's again classification. So we have the classification matrices over here, and you can see the F1 score, uh, all the precision recall curves, ROC curves are there, and the a smaller confusion metric is there, and looks like a good classifier. Now check this out. There is another option called as feature importance. So let me explain this. Anyways, we are able to see it in as part of the AutoML output. So let me just put it forth, like what is feature importance. Now whenever you train any machine learning model, you the model's output or the training should be explainable. You should be able to explain why it happened. It should not be like a black box. There are multiple libraries in the open source market right now, in the open source world right now, where by using that you can create these local and global feature importance, like why, when that in this data set which is the most important attribute, and then maybe in this inference which is the most important value because of which the prediction happened. So what this feature importance does, using this feature importance, I'll be able to understand what why it happened. I will be having that insights into that, based on which attributes the best the output is coming. If some output is coming, if a prediction of particular class has happened, then that is because of which attributes, like why did it happen, right? So those options are there as part of feature importance. So you can see in this diabetes classification option, we can see that pregnancy is one of the most important attribute which is having very high feature importance. So in this data set, pregnancy is more important as such, and or is the deciding factor. Because of that pregnancy value, someone may be diabetic or may not be diabetic. It's having a lot of weight over there, or contribution to the deciding factor. There is a very high support of this particular feature to the contributing output. Now, age is the next major contributing attribute. Serum insulin, body mass index, blood pressure, plasma glucose level, tricep thickness, diabetic pedigree, patient ID. Anyways, patient ID we should have removed from there. Uh, right, patient ID is that unique identifier in the database, which we actually should have removed from it. But anyways, no. Uh, you can see that the most important attributes are these: pregnancy, age, and so on and so forth, and the importance is coming down. So this option, this concept is part of the offering from Vertex AI called as explainable AI. Like if I just take you back to my diagram, whenever you create these models, you will be able to explain why something happened. So let's say explainable AI over there. Right, like why something happened, what's the feature importance of it, what why and it's no longer a black box. It's very important, a pretty good feature which they have added as part of Vertex AI. So if I take you back, so what else is offered by Vertex AI? If we just have a look at the other values, so this is another classification, a video classification over here. So now there is one thought which I am hoping that someone will ask in the chat window, that I just showed you the feature classification in, you can say, in this scenario where we had the attributes and age and various attributes were there. What happened if we had images, right? Then how will it look like when you explain the feature importance in images? Then how will it look like? So I will just cover that part, And I will be using one picture from GCP only, from their documentation. Let me just quickly look up for that picture in my secondary screen if I can find it. Okay, so please notice this. So now I showed you what happens in terms of if you have normal attributes in your data set, if you have a normal data set as such. But what happens in terms of images is what we have to go through. So now check this out, right? So in this classification, uh, so those the highlighted pixels, the green part is basically representing or showing uh, or it's like the pixels which have contributed strongly to the resulting prediction, like cat versus dog. Those are highlighted right now. So those green ones are the ones which are highlighted over there. And right, so in this picture, basically the eye and the nose and some part of the of the head as well is one of the contributing factor. And here these whiskers, I think mostly the whiskers are a contributing factor, and the pattern of the eye and maybe the shape of the ear and so on and so forth. Those are the one which are contributing right now strongly to the cat prediction which happened over there, like cat versus dogs. And this is another option over here where Daisy, there's a photo of the Daisy where it's like what has contributed is being uh, covered. So if you look up for this page in the GCP documentation in Vertex AI, you can say tab, you will be able to read and find more about the explainable AI part of it, right? This is something which is very important. And all the leading machine learning platforms provide that functionality, right? It's not that it's only in Vertex AI. We have the same functionalities in other clouds as well. So okay, now let's have a look at what else do we have. So basically most of them are classification. Let me see if we have anything regression as well. Okay, so this is one of the old pictures. Let's go back, and I think that's what we have opened. Okay, so let's close these pages now. We don't need them anymore. So okay, because of some reason I only did classification. So but you can relate with it, right? RMSE will be there in regression matrices. You may have MAE and so on and so forth, right? So similar matrices will be there as well, but you get the point, like what is going on. I hope you guys are getting the point as such. So what we have done is we have talked about data sets, managed data sets. Managed data sets are of four types, and four types will have some objectives as part of them. And there is a labeling task which can be done. So that labeling task, you can create the labeling task, and then you can have Google can provide the labelers to you, or you can have your own workforce which can label that for you. Secondly, you can have other sources, but you can only do custom training. Then you can have explainable AI. It will do the feature importance. It will explain which pixels are more important, which pixels are uh, right. So let's say the feature importance part has been done. Okay, so let's go back to the Vertex AI. Let me see if I can show you more details over here. I have some custom jobs here. I will walk you through the custom jobs. Give me some time. Let's see anything else which we want to cover right away. And this is hyperparameter tuning jobs are going on here. So in case you guys have any question, feel free to ask that in the chat window, right? Anything which you have in mind, just put it in the chat. And we have a team answering the chat today. So even either I'll answer it or maybe the team will answer it. I'll also pick up your questions maybe at the end of the session or something. So please do that. Okay, so now let's move into the custom training part of it. Like how do we do the custom model training? Where do we do it? And how do we do it? What options are there? Can you containerize your machine learning model? How do you create the MLOps pipeline? So that part. So if you want to create your custom code, you need the development environment. Now, as part of the development environment, what they have done, they have provided one option called as notebooks. And these are Jupyter notebooks, right? Jupyter Lab will be there, and you can uh, basically create that. So there is one option, notebook option now, right? So you see over here these notebooks like that. So if you create one notebook, right? So I have these three notebooks. I think all two of them are running. Third one is not running. Let me start that. I'll start it. So at the back end, where is it? So literally one compute instance will get created, and this notebook is having that. The backend is that virtual machine, is that virtual instance, is that compute engine or instance over there where it is running. So you see those, so those three notebooks which I created earlier, they are having one CPU, 3.75 GB RAM right now. So the backend is actually this. The machines are running in my subscription only, and these are literally virtual machines over here where some preset environment will be provided to you. So the good thing about notebook will be that your development environment is in the cloud itself, and anything required like Google's SDK or any other popular libraries will already be pre-installed inside that, right over here in this compute instance. So these are the compute virtual machines which we have in the in our console, right over here. So uh, okay, let's open them up. So let me open, let's move it to one side, and let's open these. I have different examples over there. I'll show you how to create another new one, right? If I click on this new instance, right? If I click over here, you see that there are some options available. Like I can have Python 3, which will have scikit-learn, pandas, and other dependencies over there. I can also have Python 3 with NVIDIA GPUs as well. uh, with which GPU you can select it for the TensorFlow Enterprise, PyTorch, and TensorFlow Enterprise with which version 2.3, 2.5, with or without GPU, like that. R and other Kaggle Python as well. So Python images for Kaggle notebooks supporting hundreds of machine learning libraries which are popular on Kaggle. So you can set some specific uh, flavors of the instances are also there. Click on any one of them, right? As per your requirement, you click on something, and then you have the environment, like it's how many CPU do you want, how much RAM do you want. Let me just show you. Let me click on it, and let me see if I can show you how big can it go, or how what is the options over there. You select it, like I am actually, so my subscription is not an enterprise grade subscription. So I have some quota limits over there. Like I have a CPU quota limit. So I won't be able to create very big machines in my subscription. You in your production grade subscription do anything which comes to your mind. But right, so that's why I have all my machines are these small ones. But you can have very big, pretty you can say massive machines as well. You see this 1.4 TB RAM, and you can explore it further, right? So you select it from here. GPU, if GPU is supported, it will show over there. Some other security options are there: shielding of the VM, uh, networking option, permission extension, security options, and you basically click on create. The pricing is on the right hand side, and the notebook instance will get created, right? Once it creates, it looks like that. And then when you click on this Jupyter Lab, your Jupyter Lab open in the browser. So I'm accessing this from my laptop, but the notebook is there in the browser itself. So my development environment is now in the cloud. I can have a proper network around it, and with those VPCs, we'll be able to make sure that we are doing the modeling, or the training part is going in a secure, in the secure location, right? It is not happening. Uh, we are taking care of the security as well along the way. Just give me 1 second. Let me just quickly check the chat and everything. Okay, great. So right. So these are some demos which I have created for you. Uh, So these demos are taken from the GCP's documentation only. So those who are thinking that how can I reproduce these demos later on, or these examples, or everything which I'm just telling you about, how can I reproduce it later on? You can go to the GCP documentation, go to Vertex AI, open the notebook section, and you will find all the notebooks over there, all the instruction over there, right? So everything is the credit goes to GCP, and please find it on the documentation, in the documentation. Now here, okay, so now the custom training will be done. You can say this is where we are doing the custom training from using these notebooks over here. Now if I just give you a quick walkthrough of what I have in this, let me just quickly give you a quick walkthrough of that part. And right, so we are installing few specific SDKs as well. Google Cloud Storage SDK, Pillow is being installed, NumPy as well. And this is my project ID. So I have copied my project ID from, basically from, you can say, if you just go back to your click on your project over here, the project ID will be available uh, in this location. So that project ID, you copy it, and that will be used to connect the notebook with the with this project. Now what happens if I am not training in the cloud, if I'm doing the training on premise? So right now it didn't ask me to authenticate. I am able to go through the you can say model training without any authentication, because this notebook is already attached with my workspace. So otherwise you have to authenticate, and then you do it. You can create some service accounts, and with that you can authenticate and you can work with it, right? Okay, so now create a storage bucket for storing of your data and for storing of your output as such. So we are listing the make bucket is being used. It is creating that bucket right now, the one which I was showing you earlier, where all the data is available in this for the demo. We are importing the Vertex AI SDK for Python, basically the AI platform library over here. And there are hardware accelerators also available. So if I'll show you this option again, but the meaning of hardware accelerator is basically that as you already know, GPUs are very fast to train the models on. If you're doing something with convolutional neural network or deep learning, then your GPUs are, you can say, a very must for your model to train uh, faster. It may take a long time without it, right? For on a big network. So with Vertex AI, you can get those accelerators. You can have those hardware accelerators. You get those GPU instances. You can specify how many nodes do you want. You even have the ability to provide some worker node. Like you, if you want, you can have parallel. You can say you can have parallel model training in multiple machines as such. You can do a data parallel. You can say you can have your data in multiple machines. You can even have a model parallelism over there, where the model is so big that the layers of neurons are in different uh, GPU nodes as such, or GPU, or on multiple machines as such. So model parallelism and data parallelism can be achieved. To achieve that, you need that cluster architecture. That cluster architecture can be provided. You can select it. How many do you want? Do you want a parameter server or not? And take your training further. So you can see some options are there: Tesla K80, 4, and there are more other options are also there. More you can say latest accelerators are also available. So right now, what we are doing, we are using some GPUs at training time, and we are using some GPUs at the inference or the deployment time as well. So the accelerator type is Tesla K80, like one is being used right now. Now, if you notice this, we are setting up some, you can say, pre-built containers. Now, if I just take you to the main parts over here, so the machines which are being used right now is N1 standard. Virtual CPU is 4, and over here, right? Basically, we are training one convolutional neural network in this example. So that's why you are seeing this epochs are coming over there, and they are telling us various approaches when we are doing distributed training. Then how do we do the training? Like how do we, should we have a parameter server? Should we do data parallelism or model parallelism, or how do we do it? So those options are. being specified or selected over there. So 20 epochs are there, and the training script is being written. So we have this script called as task.py. This is basically being locally written right now in the local location. We are not running it right now. We are just storing it, and everything is parameterized. If you see, we are using argument parser to pass some argument at runtime to this script, which will be running at the deployment location where it is getting trained right now. So argument parser will be catching the arguments at runtime. Learning rate, epochs, you may have some sort of other strategies as well. So over here, so this is where I was telling you in the starting that we'll be training one convolutional neural network, and I am assuming that I'll just give you a quick walkthrough. I actually have a slide deck prepared on convolutional neural network, so I'll give you a walkthrough of the overall uh, major elements in CNN, and maybe in another session we can go in more depth, but I will just quickly share my screen. And this is the wrong end of the presentation. Let me switch the screen. So this is basically where I have that. Okay, let me go to the correct page. So let's go back and read the step first. So you see this. We have this convolutional layer is here. We are using Keras. Keras is part of TensorFlow now, right? So we are using a convolutional layer, and there is input shape is there, 32 by 32, 3 channels are there. Max pooling layer is there, another convolutional layer. ReLU activation function is there. So max pooling is happening again, and some layer is to flatten, and then dense layer and soft max, right? So then we compile this, and so what is going on? I'll just give you a brief gist of CNN, and then this may become less demystified as such. So we are training this CNN on Vertex AI. So what is convolutional neural network? It will have those various layers as such. Now convolutional neural networks are inspired by human vision system. The you can say the experimentation was done in 1950s to 1960s, during at that time by you can say by a pair of data scientists as sorry pair of scientists as such, and they did the experimentation on the retina of the dead cat, and they found that the how they created some initial understanding, or you can say hypothesis, on how the visual system of uh, mammals or human beings may work. So they had those simple cells, complex cells, those various type of center surround cells were there. They invented, they sort of gave new terms. They found various ways in which the humans, you can say the cat's neural network was, or his her, you can say its sort of visual system was working. So inspired on that, we have the convolutional neural network. Now, convolutional neural network basically what it does, we extract the features from the pictures, and then we do a sort of classification at the end of it of the neural network. So what when you have any convolutional layer, which I was showing you in the code, basically this happens. There is a filter which is going over the data, and if I go next in this slide deck, this is the meaning of convolution, that we are moving that filter around on that uh, you can say picture, or maybe the input feature map. Now when you will go down the convolution neural network, you will create multiple feature maps, and multiple filters will be there, and these feature maps will be stacked together, right? And that's where the features are getting extracted from your input data. So in convolution neural network, this is what we call as convolutional steps, where convolution happens and we multiply the filter with the input you can say values over there, and we get the output feature map. So this is another example of convolutions. And the major logic which we have over here in this is that with the help of these features, we'll be able to take out the edges, vertical edges, horizontal edges, or maybe other edges uh, from the input image. If you can train a a neural network, if you can train those, if you can find the correct weights of the filters, then literally it will end up classifying between flowers. It will end up classifying between maybe cats versus dogs and any other thought which you have in mind right now. So this convolution neural network, this particular filter is finding that vertical edge over there, and we have filters which will find the horizontal edge. So this is one filter which can find the horizontal edge in the data. There are some other filters also. These filters, when they uh, uh, these filters will be able to find other type of, you can say, edges in the data. So in convolution neural network, another concept is there called a stride. Stride is basically like when I'm moving that filter around that particular feature map, then that is moving with how much, you can say, that is moving around with some particular pixel unit. So one stride, two stride, or something like that in that sense. So this is when you want very granular inputs, you are looking for that very granular stride. Otherwise, you can, if you are looking for that aggregate overall type of features, you can have a bigger stride as well. Now, one of the problem which happens when you multiply, let's say, a bigger metric with a smaller metric will be that a dimension will reduce as such. So to make sure that, and your problem statement might be very complicated. So to ensure that you have a deeper neural network, at the same time you at the same time you want to train it as well, you need to have some padding. At times you need to do the padding in the feature maps as over here. So the this output size doesn't shrink very rapidly, and you are able to create deeper neural networks as such. So this is where the filter is spilling over, you can say, was spilling over earlier. So the padding has been done on all the sides. Another concept, so this is basically what happens when you have multiple channels, as we have in that example where three channels are there. So you can have multiple, you can say, the filter will be having multiple filters will be there, one for each channel over here, and then the aggregate output feature map is getting created at the bottom of the page. So as part of the convolution neural network training, at the end of the day, we are talking about that the filter weights will be learned during the model training. So something like this happens, where you will provide the, in this supervised learning example, you will provide the labeled data set, and those filters weights will be learned, and uh, back propagation will happen, and the adjustment of the weights will happen during the model training. So yes, it will, in a big neural network, it will take a long time for it to train, but uh, that's the logic around it. And convolutional neural networks are, as we were talking about, that they are inspired by human, or you can say the way the our brain processes the data. So similarly, these are also one of the, you can say, few of the go-to architectures when we do some sort of visual or computer vision type of analysis. This is basically what ReLU does. ReLU will be, so in our human brain we have the neurons, and the thickness of the axon at times will make sure that the signal is going ahead or not. So what happens over here in this example, the ReLU layer is doing that similar thing. It is eliminating those low intensity negative values over there, or signals right now, and it's just converting those negative values into three. So that is going on. I was showing you that max pooling is being used in the example which we are saying. So this is max pooling. You basically can do max pooling or maybe average pooling as well. So max pooling will take out those dominant features from the extracted feature previous feature map. And if you can see right now, 8, 6, 9, and 9 are the dominant features. So max pooling has reduced the size of the output feature map as well, and it has sort of, uh, you can say, is focusing more on the dominant features rather than the lesser important features in the picture for the purpose of classification. Average pooling does the, you can say, aggregate as such. Over here, if you see that we are doing the aggregate right now, 4956, and aggregate is 6, 3.3, 4.3, and 5.3. So the average value is getting uh, pulled out. So this is that, you are summarizing what features are being extracted, and that average pooling will help you do that. Now the convolutional neural network looks like this. Like there is basically input pictures, uh, multiple layer of convolutional layers will be there, multiple max pooling layers will be there, some flatten layer will be there, dense layer will be there, and this is what we were creating in the example I was showing you earlier. So if I take you back to that example, and I will close the unnecessary tabs. If I take you back to this example over here, you will notice that we have the you can say one convolutional layer here, max pooling, convolutional, max pooling, flatten and dense layer. And then we compile this. And right now this is not running. We are simply saving it in our task.py file locally. And if you notice that we are also, if I just save that, we are saving this in the model directory, right? You see this model directory. So that's where the saved model will go. And okay, so the file was not running in that point in time. It was locally saved. Then when does it run, right? How do we do the submit of that? So now when you submit the run in Vertex AI, basically two things will come into picture. There is this custom training job class is there, where we will define all the details like the local path of the training script, the user defined name of the training script, the URI of the container image, the Python dependencies, any container which is being used. There is a run function also apart from that, from the point of view of SDK. So arguments, replica counts, how many replicas do you want if you're doing some distributed training? Model display name, machine type, are you using hardware accelerator or not? How many are you using? So those details. So if you see that this is the custom training object, custom training job class which we are having over here, and the task.py is one of the input over there, and the dependency is TensorFlow dataset 1.3, and we are training it. The accelerator type is train underscore gpu dot name, which basically we were defining some time back. If you remember, we were defining the gpus over here. So those are being pulled over there. So somewhere, so these gpus which we have deployed, which we have defined over there, they are being referred right now. So this is the model which is running right now, right? So in East US as part of models 9824. So as if I want to track something, I will be able to go to that particular model section here, and everything is getting logged for me to check later on. So if I click here, I will just cross check which version was it. East US East 1 9824. Okay. Okay. US East 1. Okay. This model is not here right now. 98, yeah, sorry, this one. Yeah, it's there. I was not reading it properly. uh, so if I zoom in over here, 9824, this is the one which got trained at that by that run. And um, we can click on it, and if you want, we can deploy this. The model properties will be here, uh, like this. So the logging is there as part of the platform, this as part of the Vertex AI service or the SDK. Now you can also deploy this model, like the deployment will be now when you deploy this model, we create an endpoint, and then we deploy the model inside that endpoint. So endpoint is basically listed over here, and this is where the endpoints are listed. And when you do the inferences with the machine learning models, there are two things which comes to mind, right? Batch prediction or maybe real-time online inferences. So both can be done. You can do batch predictions also. You can do real-time inferencing as well. If you want to deploy things in on the edge, you can do that as well. You can select those options, and then the model which is generated is more. You can say it is more optimized for and light in weight for to be deployed on the edge, to be deployed on the edge location. So if I take you back to the CNN which we were training now, okay, so let's just have a look at it, right? So we are using that GPU deploy right now, so it will further improve the acceleration. And we can obviously also use the open neural network exchange, you can say .onx compilation of the trained model as well. That will also further improve the inferencing, right? So just FYI, ONX is approximately the open source ONX. Uh, you can say dump of the file or the file format is approximately 10 times faster than any other, right? So that can also be used over here to further ensure that the inferencing is done as quickly as possible. So now this online endpoint is deployed, and we can see the endpoint is basically this 2156565. So I think that's the one somewhere here. Six, yeah, this one 565, like that's the one. And this is the endpoint to which you can do the API call, and you can do online predictions with it. Like real-time inference pipeline is what we are talking about right now. So if you, well, I don't have any I don't have much data here because haven't sort of just deployed it, didn't consumed it much. But if you can see sample request, uh, it is going to show us some sample code of how we can do inferencing with this particular model, right? So some copy paste of some platform and so on and so forth. Okay, so let's go back. Now we are downloading some test data, and then we are doing the copy operation, and the data which is being tested, we are normalizing the data, and we are doing the testing right now. So predictions, so these are predictions right now. So correct predictions are 3, total predictions are 10, accuracy is dot 3. So yeah, accuracy is not really good in this one. I didn't even notice it before reading it right now. So yeah, that is something which can be worked on. But so this is what I meant by custom training, right? Where how the custom training can be done. So let me see if I have any more examples for you, which I have created or set over here. So this is where we are training one regression model, and the details will remain similar. Now let's see if I can find you, if I can show you anything different as such. Okay, so the same, the SDK remains same. So now the good thing is these are totally plug and play type of thing. Right? If you have a proper parameterized training script, you will be able to plug in the data set. If you have a classifier, you can plug in the data set, and you can plug out the data set. You can have another you can say input file for specifying the environments and the dependency and the containerization, and the you can say Docker file over there, and everything can be modular in nature. So okay, so this is the regression analysis going on, and basically a small neural network is being used, or most of the all the layers are dense over there, and so this small DNN deep neural network is being used to train that classifier, and sorry, to train the regression model right now. And we do the same thing. We train the model, we'll load the model, we also, you can say, save the model, and we can do the evaluation of the model, and so on and so forth, right? So you can explain, so the AI part, this explainable explanation of the metadata is what I was telling you earlier, that what is the feature importance and other details over there. Let me see if I have more examples for you which I may have created earlier on. So let me see, what do I have in this one? Yeah. So I just want to explain one more thing over here. Now, when you, what you can also do, you can create your own Docker containers as well. Now, these Docker containers, so Docker images which you are creating. So, for example, this is a Docker file which we have right now. With this, we'll create that image, and finally, the container will be deployed in some deployment target. So, if in this example, we are not using the platform provided or any other, you can say, predefined you can say containers, we are using something which we are creating ourselves. So when you are training something, you can use the pre-built containers, you can use the custom containers as well. Now if you create those custom images, you have to store it somewhere. So we have this container registry option as part of the offering. So if I just take you back to here and say container registry, so this is the container registry which I'm using right now with my custom to store my custom images, and I have three different. I think as part of three different demos, I have this. If I click on one of them, this is basically where my Docker image is kept. Now inside this Docker image, all the dependencies and everything is already pre-installed. So that now what I can do, uh, this is that ready-made environment which I can further use to submit for training purpose, right? So this is that, and So this is that training. This is a Docker. We are creating that. We are creating the Docker file right now in this one. We are pulling some base image from Google's container registry, and then we are adding some work directory. We are running pip install cloud hypertune inside it, and then we are copying everything from the trainer folder into the trainer over there slash trainer. So this folder is getting copied over there. And what is the entry point when this will run? So the script is basically over here. So in this example, I am showing how can we do hyperparameter tuning. And let me see if I can show you. Okay, so let me show you this part over here. I think I will be able to show you the hyperparameter tuning here somewhere. Okay, this ran for 34 minutes. And let me see if I can create another task. We need the actually we need the data set and all that for it. So let me quickly check which data set was it. So not a managed data set. Okay, anyways, it's not a managed data set. So let's remove it. And custom training model train okay, let's say this two. Let's click on the advanced option. So nothing to select over here. Now custom container, now you have to specify where that custom container exists. So you can browse your container registry, you can specify which one, which is that custom container with all the dependencies and details as such. So this is the one. Let me see if model output directory is required, otherwise we will give it. Okay, not really. So now enable hyperparameter tuning. So now when you're doing the enabling hyperparameter tuning, you have to specify which parameters do you want to tune as such. So in this example, we have tuned three parameters. We have tuned the learning rate. We have tuned the number of neurons which are supposed to be there. So whichever and number of you can say any other hyperparameter as such. So you can specify those details as well here. So if I take you back, this you can say the this learning rate like that, and then what is the value of it? Like, are you doing a grid search, or are you doing a sort of you can say in the search space, are you doing a random search? So all those details can be specified. Which matrices do you want to optimize? What is the goal of it? Maximize the metric, like accuracy can be one of the metric over there, right? Like this. And you can give discrete values, you can give continuous values as part of hyperparameter tuning as well. And which algorithm do you want to use over here? So if you leave it default, then we have a thing called as Vertex AI visor as such, which is a part of hyperparameter tuning option which they have given. And it will internally, it's more like a black box, it internally does the hyperparameter tuning. So that is being uh, you can say that happens if I leave it as default. If I want, I can give my own options as well, that do a grid search over there. So grid search is random search is basically if you have a very big search space, you can randomly pick up the hyperparameter values, and then maybe you can say drill down in the search space and find more optimized values, and then do a grid search around that. And grid search is basically when you try all the values as such from your search space, and that's gonna be a little more expensive. But if you have a smaller search space, or maybe if that is mandatory, then you can think it through. How many number of parallel runs do you want? Early stopping or not, that can be defined over here. So maximize number of let's say trials, try it 15 times maybe. Parallel runs, maybe do three parallel runs. If I give more parallel runs, then my cluster need size needs to be bigger. So that's one problem which will happen. So okay, like this worker pool. If I let's say one worker pool zero, if I'm doing something distributed, I can add more worker pools. Do I need acceleration or not? So these are the various GPU cards which are available: K8T, P10, V10, T4, P4, like that, right? So select the one which you want and start the training. So the training which I did last time, this ended up in around the hyperparameter tuning happened in around 34 minutes. And so we have, okay, so I have given learning rate, momentum, and number of neurons as three hyperparameter. to train. And if you can see that learning rate values are over here, and it has tried it multiple times. So okay, so let me see if I can show more on the same page. Okay, so these are the 15 times which it has tried the different values, and you can see the accuracy was okay. So 15th dot 8, that is that's a higher accuracy. I think dot 8 is the highest one. If you guys can see another one, then to let me know. So this is one of the, you can say, where the learning rate value was this, momentum was that, and number of neurons was 512. So that's when the accuracy was maximized. So I can so this is my most optimal hyperparameters values out of those you can say, out of the three which we have given. These values are the most out of all of them over there. Now, if I show you a little more details here, maybe let's see if there is any more thing to talk about on this page. So the most, you can say, the difficult task of hyperparameter tuning is now just give your values and let it run and go have your coffee, and provide some sort of inputs in terms of what type of search do you want, maybe a grid or discrete, sorry, random or grid as such. Specify your search space, and then go and get your coffee, and by the time you come back, or maybe have a bigger break, right? It's not that always the hyperparameter tuning will happen in 34 minutes. It will take time. So those are your optimal values. Okay, now is AutoML something which is so? Uh, can I always rely on this? If my network was bigger, right, it would have taken a very long time. Then I really would not have been able to rely on just on this. Like, it's not that for any problem statement I can simply use this hyperparameter tuning to and it may run for a very long time, right? So you may end up on with a very big uh, you can say, with a very big bill in your hand of training all of it, right? So okay, now let's come back and see if we can find a little more details as such. So now I will just quickly confirm what uh, which part of this is untitled notebook over there. This is another demo as such. Okay, that's the pipeline part. I'll just quickly explain this. What is this pipeline concept? So before that, just a quick overview. The data sets are of multiple type. Uh, Labeling task, basically, in case you don't have labeled data, you can do the labeling task. Notebooks can be created as your development environment. Training of the model can be done. You can log everything as part of one experiment. I haven't shown you that, but you can log the details as part of the experiment. Just give me one second, guys. Okay, so now check out this. Let me just show you first what do I mean by the pipelines, and then I'll give you more details about it. So I have these two pipelines over here right now with me. One is little smaller, the other one is slightly bigger versus that one. Now, I'm pretty sure you already know, you have heard about ML ops, right? Machine learning operationalization as such. So those you can say ML ops pipelines, if you have those, so now you may have to use heterogeneous compute locations. You may have to, there may be maybe multiple steps in a pipeline. You So if I show you a bigger pipeline which I have on this page, and let me zoom out slightly so you can expand the artifacts also. So now, as part of my training steps, I may be having multiple uh, sub parts over there, right? Ingestion of data is one of the parts. So if I think of what parts will be there as part of pipelines, ingestion of data, pre-processing of data will be there, training of the models will be there, evaluation of the models will be there, deployment of the models can be there, if you have trained something previously, and now you are and now some data drift has happened. Data drift basically means that if I have deployed my model in production, and now because of the change in the pattern of the data which is coming for inferences, the it's not performing well. That's basically data drift. So if that has happened, then we literally have a concept called as data drift monitor here. So you can do continuous monitoring of your models. Like it's gonna tell you when the model's performance will degrade. You can do the retraining after that. So now even if I have to retrain the model, when I retrain the model, is it the new artifact or the new trained model, is it outperforming the previous one or not? If it is outperforming, then we deploy it. If it is not outperforming, then we don't deploy it. So that MLOps pipeline, that multiple steps which can be done, which can be stitched together using heterogeneous services in GCP, is is provided as part of the pipeline option over here. Now uh, with these workflows, or with this Vertex pipeline, you can apply your machine learning MLOps strategies to automate and monitor any repeated process which you are doing. You can experiment by running machine learning flows which are using different hyperparameter values. Number of training steps can be changed, iterations can be changed. You may have multiple pipelines. You can reuse these steps again and again. So if you see this one over here, we have some tabular data set, and then on that tabular data set, we are basically doing AutoML, and then some classification is going on top of it, and then some conditions, and then we are doing a model deploy, and then there is an endpoint creation. So everything is now stitched in something which can be scheduled. We can put more checks over there, that if the next time if the model is outperforming the previous one, then only do the deployment. Otherwise, don't do the deployment. We can have some we can integrate with with DevOps tools as well. We can have some gated releases. We can have human checks also on the way. But this concept of stitching all these steps together, all the various ingestion, pre-processing, training, evaluation, and deploying step together, is called as that MLOps pipeline, which we have in the screen right now. So similarly, this is the bigger one, and I have a smaller one over here where another model is getting trained. Another model is being building of sentences. There's a smaller deployment of like a hello world type of you can say approach. And how have we created that? The creation has been done with this Python SDK over here. So it still doesn't have that drag and drop functionality available. You have to design the pipeline using code, or you can use some sort of infrastructure as code option as well. But right, and the overall thing can be further scheduled to run on any iteration which you want. So this AutoML, sorry, this MLOps is the MLOps functionalities are provided as part of pipelines. Now, what I will do, I will just quickly take you through one of the architecture which I have taken from the uh, you can say from the GCP's documentation. And this is the overall architecture of what we have discussed about, right? There are notebooks are here on the bottom of the on this diagram. We have the deep learning environments are there, deep learning virtual machines and deep learning containers are there, some pre-built containers where all the which will be having all the dependencies required to train your models. AI accelerators are possible. You can have the logging as part of one experiment, so that experiments are here. Data sets are there, data labeling can be done. Features can be stored and can be accessed on a very low latency, you can say in a very, you can say, less latency as such when required. Training can be done. AutoML is there. AutoML basically is having multiple you can say options are there. We can have vision, video intelligence as part of AutoML offering, natural language processing, translation, tables, predictions, explainable AI is there, hybrid AI is there. We can do the with the help of continuous monitoring with drift monitor. We can uh, do the model monitoring over there. So this is you can say overall architecture of how Vertex AI looks and feels like, and all the offerings which it provides are listed down in one page over here. Now, if you have any questions, then do let me know about that in the chat windows, so chat window as such. And what I will do, I will just let's do a quick comparison with Azure Machine Learning Service as well, right? So this is not part of the agenda, but uh, I think I have some time with me. I was expecting the session to last for another 30 minutes, but I think we may end up slightly earlier, which is not an issue. But let me just add few extra things as such. So I'm just trying to log in into my Azure portal so I can do a quick comparison out of the box between the Vertex AI and the Azure Machine Learning Service, which is one of the main offering in Azure. Let me see if I can find my Azure portal. So, okay, something is not responding. One second. Give me a second. Let me quickly check. Is it something wrong with my internet or what just happened? I'll just quickly switch my network if if that will resolve it. Okay, great. So basically, uh, there was some issue with the network. I just switched it, and now the pages are opening. Uh, I think I have one Azure machine learning instance deployed here. So we can compare both these services side by side. Let me quickly log in and then show you that page. Okay, great. So this is, you can say, I don't think if when there are many documentation around comparison of both these services yet, but yeah, so let's check this out. So basically this is where we have the let's open the Azure machine learning service, and I'll give you my opinion on them. I'll give you just my opinion, and then you can go for more, you can get an expert opinion from some other sources as well, but let's just have a look at my opinion as well, right? So now this is Azure Machine Learning Workspace, and that is the Visor. Sorry, that is this is Vertex AI. So now the notebook, dataset concept, labeling concept, experiment concept, training concept are available in both of them. Like even in Azure Machine Learning, we have the notebook option, AutoML, dataset, model option, endpoint option, pipeline option, the MLOps pipeline, that one, right? Those are already there. Data, some other things are there. Overall, if I tell you some differences, uh, one thing which comes to my mind right away is that in Azure Machine Learning Workspace, when I try to get my data from various locations, I can get my data directly from relational databases, Postgres, MySQL, file share, blob storage, data lakes, and so on and so forth. Uh, which direct integration, so in terms of Vertex AI, the direct integration is available from the point of view of object storage, like the cloud buckets. uh, I'm not saying you cannot get your data from other locations, but by registering your data stores, the number of the steps required in the code reduces. The way in which the data is pulled, that reduces. So that is something from where you here also we can get data from other sources, right? But uh, the ease of use is something which I feel is something which we can give to Azure Machine Learning Service. We can give one, maybe half a point to that over here with the help of this data store. So labeling is there, and the pre-built environments which I just showed you as part of as part of Vertex AI. The when you talk about containers, custom containers, and default and some pre-built environment, those are here as well. See, we call them curated environments and custom environments. So this is where both the platforms are providing the same functionality. Now let's think about some differences as such. So we have the same notebook concept here. Now there is one thing, when you create these notebooks, right? They provide more option. Like if I create one notebook, okay, so I have to fill up this page. So I'll just give some details here, that this is, you can say, notebook. And okay, so CPU GPU notebooks created, right? So now once it will open, you will see that there are four options. Like one thing which I think is different between these two platforms will be will be in terms of you can say that uh, that we are you can say uh, that in Vertex AI we can do the modeling with Jupyter Lab. In Azure Machine Learning service, we can do the modeling in VS Code, Jupyter Lab, Jupyter Notebook, and RStudio also. So they are offering four things over there versus Jupyter Lab as such. And personally, I use Jupyter Lab or Jupyter Notebook in anyways, so that doesn't give me any other advantage in any of the platform. Now, if I think about the differences, there are some things which I like about Vertex AI a lot. So you see the dataset option. This is so advanced over here. Uh, Let me open it again. So as part of the data set, you directly will be able to specify that your video data sets, you can directly you can do action recognition on top of it, classification, object tracking on top of it, text uh, classification, tabular, and image classification. Now that same level of data set creation is not there in Azure Machine Learning Service. I can do my object detection, I can do sentiment analysis, we can do text analytics, but it's not how we can do it in Vertex AI. This is where we can give them a, you can say, some major point as such, that here as part of Azure Machine Learning Service, only two things are there. There is a tabular data set and there is a file data set. So tabular data set is where when what we thought about, like pandas data frame or some table as such. And file data set is the one where we have when you are doing your model training with on multiple files, like image data set. So you can say that image option there here is available, but the video option available uh, as part of the Vertex AI, that is something which is very interesting, which is missing in this Azure Machine Learning Service. You can still analyze it, but not with the same ease of use. Now, something where we have to give Azure Machine Learning a big point is in terms of this designer. So this is something. Now see, the cloud platforms are right now trying to are promoting the AutoML. AutoML is reducing the requirement of you can say of so in the teams which we have, the teams may not have the same expertise in terms of programming or in terms of data science. So uh, to reduce that dependency, here in Azure Machine Learning Service, we have this option called as designer, where you can do a drag and drop and you can design things. Now don't get confused, this is not the same thing as pipeline which I showed you in the Vertex AI. So Vertex AI has no option in which I can drag and drop and create my you can say machine learning models without any uh, even in terms of, you can say, doing things you can say developing something way faster, right? This can help us out in that. So this is where we can give one point to Azure Machine Learning Service to have the designer. um, so I can say, okay, as part of the AutoML over here in Azure Machine Learning Service, there are more exit criterias. I have seen that I can specify smaller time windows as well, and there are more control in the exit criterias which we can specify if we go for AutoML here, which are missing in Vertex AI as such. But the AutoML of Vertex AI is getting that edge when it comes to video based classification. That is amazing, right? That is not happening in Azure Machine Learning Service yet. So both the platforms have their own plus points. Both the platforms have their, you can say, some places where they can further work on. And from the point of view of which one should you use, uh, any one of them which your company is maybe working on. Maybe your company is oriented to GCP, or your company is oriented to any other platform as well. You learn that first, go into it. And the basics of machine learning will be way more important than learning any tool as such, or learning to do it here or versus there, uh, in a sense, over there. So, right, so if you have any questions, do let me know in the chat window. This is what I had for the session. And we will be, you can say, we'll finish the session a little early, as right, earlier than expected. uh, and just to give you just to tell you the other details, we I will be putting the quiz link in the chat, or if anyone from the team, please put the quiz link in the chat. Now, right now, approximately you have 2 hours to give the quiz. The quiz is pretty straightforward. The quiz is on machine learning basics as such. So you complete the quiz, and we will be announcing the quiz winner in few days on the event page itself. So for that, I need few days to just have a look at the output of what you have done. We'll put the quiz link in the chat. And as I was already showing you that the with the quiz you can win uh, books sponsored by Pact. So please do that. And those who have not yet subscribed to the to Tech Scalables page, please do that, because we have multiple upcoming events which are planned. And in case you are subscribed to our company's page, then you will get that notifications right away, right? So if I show you upcoming sessions which we have planned, there is one session which is planned on, uh, you can say, so I can open the next three as such. So there is one on deploying a cloud native application with Azure services. This is planned, and basically here we are talking about AKS, Azure DevOps, and live monitoring of application and containers, and so on and so forth. Mamta will be the speaker for this. This session is basically going to happen on August 10, uh, like that. And Qflow is going to happen. This is one session which is planned for August 12th. I'll be taking that session, and we'll be understanding that how Qflow can help us in creating the machine learning pipelines. And this is where we are doing the, you can say, this is the ML toolkit for Kubernetes, right? So we'll see how Kubernetes comes into picture, and how can we train those models or deploy those models in Kubernetes. So this is the a pretty interesting session. So join us for that session on 12th August. And we'll talk about Qflow mission. We'll talk about the training. How do we train models? How do we manage the complex ML systems? How do we do hyperparameter tuning over there? And there is another session which is designed on MLOps. So we actually are running one series called as Tech Edge series. So as part of this Tech Edge series webinars, we are doing webinars on the latest technology, or we are doing webinars on the skills which you may need in today's world to do to excel in your career. So this is one session which is planned for 24th August on MLOps. So we will understand the entire MLOps pipeline, and there is going to be a case study which we are going to solve. And as part of the case study, we will understand, and this is related to Azure. So we will see Azure Machine Learning Service in picture, and we'll create an MLOps pipeline, right, over there. So join us for this session as well. And in this one, we are going to talk about container instances, DevOps, Kubernetes, machine learning service, MLOps, Onyx, Open Neural Network Exchange, and we'll have a case study. Target audience will be data scientists, app developers, AI engineer, and DevOps engineer. So if you are looking for all these links, just go to the company page, and on the company page, you can simply join us over there. We post pretty religiously over there, and so what I will do, I will just I'll just put the link of the quiz again in the chat. You can answer the quiz till you have 2 hours with you. So we'll close the quiz at 12 in the night. So you can try to finish the quiz before that. And as I was mentioning that we are a training and consulting company. So those who are looking for consulting services on any of the latest technology, or if you're looking for the trainings on any of the latest technology, maybe you want to learn more about GCP, Azure, machine learning, containers, Docker, Kubernetes. Uh, so you can contact us. Team, please put this link in the chat window, right? I will simply answer your questions now. So I'll go through the chat. I'll respond to your questions over there. And if you have any doubts, any thoughts, do let me know. I'll answer them. Or after that, give you a quiz, get the chance to win the book, join us for upcoming sessions. I'll just mute myself for a few minutes and let me read the questions over there.
Hey Shivam, thanks for the amazing session. Uh, Guys, we have posted the quiz link. In case you're interested, do submit your answer in next 2 hours, and we would be announcing the winners of the quiz in couple of days. On the screen, we have left our email ID and the phone number. You can connect to us for any of the queries related to any of Azure batches. Upcoming Azure batches are AZ400, which is Azure DevOps, starting in the month of uh, August. So, in case you are interested, do enroll. Thank you. Thank you, everyone, for tuning into our webinar, and hope you people enjoyed the session. If you have any queries, you can certainly get in touch with us on our LinkedIn page, or you can also connect to Shivam directly. I think we are done for today's session, and we don't think any questions are pending to be answered. So, thanks a lot for tuning in, and stay tuned for our upcoming webinars. Thank you.